And it sounds like it's the buzzword of the day, and it sounds like it just started, but in reality, it's been ongoing on and off with starts since the 1950s. And my entire presentation, the slides are generated as a React website based on Claude. I didn't do it, it wrote the code. I simply had the content that I gave it and told it to get it ready to present. So this is actually not PowerPoint or anything else, it's just a website. And the start of all of the AI era kind of started in the 1950s with Alan Turing, who came up with this test to decide whether or not a machine is intelligent or not. And it's called the Turing test. The idea being, my colors do not show up in here. It doesn't look as nice. But anyway, there's a little bit of a graphic here to kind of demonstrate what it is. And it is that you stick in a human interpreter with two participants, one human, one computer, and you have it ask questions, and you have that human person interpret those answers and have a fluid question with them. And if they can't reliably distinguish between the computer or the human participant, then we can declare the computer to be sentient or intelligent enough to function as a human. And the problem with it is that, at least from the start in the 1950s, we didn't have the computer technology to make that happen. And as we've gone on during the eras from the 1950s, it's been stop and starts because there's been these what's been considered AI winters of research funding, dollars, and innovations starting and then stopping, partially because of the technology not being there, partially because our understanding of how to generate AI and get it going to do the tasks that we want it to do, how that's always been a little bit of a laggard of the dreams are bigger than the reality. In the 1960s, we originally thought we had it all started and that it was going to roll, and we had machines that could do machine translation, but the inhibitor there was that they were rule-based. They were, if I see primary use cases were like language translation, but they would see things like, if I see a word that's hello, I would translate it to hola in Spanish. But once you get into nuance and grammar and punctuation and the meaning behind words, the machines couldn't do it based on rules because we can't understand them based on rules, because some of them are just nuanced human interactions. Some of them are also, how do we move our body? How do we communicate without saying words? And the machines can't rule-base that because we can't do it. And then, so that dropped off interest in research on AI in the 1960s, and especially with the limitations of what was originally the hot topic, which was perceptrons, which are this idea that you could encode an entire layer of knowledge that would be your transform layer. It would be a layer that represents your knowledge in a graph, and that graph would then be able to produce the results that you want based on the input you give it. It would basically map from inputs to outputs in a single layer. The problem was that only took us so far because, again, there's hidden knowledge that we don't always know how to represent. And so those perceptrons failed because we couldn't extend them to multiple layers of understanding and knowledge. And also, we also had issues with DARPA funding, and in the 1970s, there was quite a bit of a budgetary crisis at the federal level that translated to a budget crisis in the AI development world, because most of the development of AI at that point was education-based in universities. And then in the 1980s, we saw an emergence of new technologies. Personal PCs came about. People started thinking, I can democratically develop AIs. I can use Lisp, which was the lingua franca for AI development at the time, can represent anything we want because it's flexible. But the problem was that everything at that point was being developed on something called expert systems, which was I can take an expert in a field and I can encode their knowledge in a computer, and that computer can function as the expert. But the problem is that if I train using an expert system, something like a doctor is going to have to make decision calls of a toss-up between two things that are of equal value, and saying that what's the thing that I value greatest with context, and maybe it's saving a patient's life as opposed to successfully finishing a surgical operation on that patient because they might die from it. Those sort of nuanced decision-making, the expert systems were unable to model. And then finally, in the mid-2000s, with this stop and starts, there was kind of a dirty word scenario of AI, so everybody had to rebrand themselves. And there was this rebranding of, I'm not doing research in AI, instead I'm doing research in machine learning or analytics or cognitive systems or intelligent design. And the problem there is also that some of these fields previously existed. So now we have this muddled definitions of what is AI, what is not. Where is And kind of going along this, some of the key milestones, I think that if I'm going to do a 30-minute presentation, I will go quick through this part. But Claude generated a nice timeline and I loved it. I wanted to keep it in there. We talked about the Turing test that happened in the 1950s. And if I keep scrolling down, there was this coinage of the term artificial intelligence during a conference of everybody that would matter to anything in the cognitive science world, psychology world, computer systems world. In the 1950s or 1956 at Dartmouth College, there was this conference to where they declared this is what we're going to term AI or artificial intelligence. And from then on, that was when it was considered a field of its own. And I mentioned perceptrons, which were the first learning pattern algorithms. And then in the 1980s, the expert systems that again, also boom and busted. And a lot of these followed emergences of new technology or new ways of thinking of how you do AI that seemed to be promising, seemed to be the answer to the question of how do we make artificial intelligence. And it always ended up being that we came up against a wall of limitation of that system doesn't completely work without some additional breakthroughs. And one of those major breakthroughs was in the 1986, Hinton, Rumelhart, and Williams. They came up with the idea of a neural network, a modeling of let's have the machines act like the brains that we want them to model anyways, and have a neural network, a network of bits of information or logic designed as a neural network, a network of individual nodes that have individual bits of information that can make decisions. And as a whole, across that entire network, you can get decisions made with intelligence behind them. And that made way for a lot of the initial breakthroughs on modeling problem spaces. And the big boom of that was in 1997 when Deep Blue was able to beat Kasparov, I think. Yeah, Garry Kasparov, one of the world champions in chess. There's a little bit of controversy on whether or not that truly was a win for the machine, because it ended up being a 3.5 to 2.5 point win for them. So it came down to a decision call in giving half points for the end results of one of the games. And in looking back, Kasparov also wrote several books about the experience and said that he wasn't sure he was playing to his best when he was playing the machine, because he's used to seeing a human on the other side of the chessboard, and he's used to playing against that human visually as well as on the board. And then we had the deep learning renaissance in the late 2000s of coming up with supervised and unsupervised ways of categorizing data, because all of these things are all ways of turning some knowledge that we have into a computer representation of that knowledge that we can work with. And some of the new ways that they found was we don't have to give it all of the data with all the answers pre-programmed in. We can give it unsupervised data. We can give it data sets that don't say, this is a cat, always categorize this as a cat. This is a dog, always categorize it as a dog. And here are the features that you can use to distinguish it. Instead, it's here is a cat, here is a dog. Decide how you can distinguish these two from each other. And then along those lines, we also had IBM Watson, which was a big initiative from IBM and their Watson Labs in 2011 to develop a system that was capable of answering trivia questions faster than humans could process them. And the insight there was that they could take natural language questions, which were meant for humans, and process them, turn them into something that they could ingest into their knowledge graphs that they have, and spit out the answer faster than the human could do the same thing in their brain. One of the other big breakthroughs is AlexNet, also students of Hinton. So one of the guys that was part of the backpropagation in 1986, one of his students is actually associated with AlexNet, which is the first system to drastically improve the ability to categorize images. And the kind of the way that it did it is this deep learning model where information is first decided. The model is first built to decide whether an image should be classified as a dog, a cat, a horse, a car, and then that information is fed back into itself so that it can learn further details to see if it can refine its models to make itself more correct over time. And then kind of one of the other big champions of this is that this ends up resulting in the ability to create larger models that are more refined, more complex, without as much space being required, because these models are able to now basically prune themselves, clean themselves up, make themselves smaller. Is that they could do things like beat world-class champions at Go, which is a vastly more complex game than chess. Chess is a single board, 10 by 10 square. Go is a larger board, and the point of chess is that you capture pieces, whereas Go, it's capturing space on a board, and those landscapes of the board change constantly. So you have a lot more permutations, a lot more complexity, and a lot more nuance for Go players versus chess players who tend to play common patterns that they've all learned. And then finally, some of the last bit of ones is in 2017, Google published a paper talking about attention is all you need, about basically the way to build intelligent systems is to have an attention model. An attention model basically points at the bit of data that is most important for the question that's being asked or the information that's being retrieved. And that if you weight the information and weight the question, you can decide the best matches for those two. And that gave rise to the basic model for what ends up becoming ChatGPT, which doesn't show up yet, but it ends up being that OpenAI came out with their GPT-1 model, which was their first foray into doing something called large language modeling, which is taking all of this knowledge and basically pumping it over and over and over on itself so that it can learn more in-depth bits of knowledge to a higher degree to answer more complex questions. And then basically over time, then from I think it's 2019 or 2018 to 2022 is this slow progression of the complexity of those large language models. And in 2022, 2023, we saw ChatGPT finally be released with their GPT-3 model. And that is the kind of like starting point for everybody saying, the AI is here, AI is booming, AI is coming. And everybody wanted to have their chatbots, and that's where you see a lot of companies infusing chat AI into everything they ever have. So you, instead of talking to a customer service rep, you're talking to a chatbot. And then kind of the giant thing here is that basically there's 74 years worth of development here. This is not a new thing. This is a new old thing. And to jump into that more concretely, the big boom is kind of also the key point of this is an algorithm called transformers. And like I was saying before, there's this idea of neural networks of modeling the brain, of how the brain is wired, modeling that in the computer, and that's how you'll represent your information and how you decide what's truth, what's not. The big point is that those neural networks have different weights on different paths between each of those nodes, and that distinguishes what's the right path to take whenever any question or task is given to it. Transformers are a way of taking that information and transforming it based on the context. So I have specific bits of knowledge that I've learned. My model is fairly large because I'm a large language model, but I want to answer a specific question, or I want to have multiple questions chained together. That context becomes something that can be fed in and be part of the transformer that becomes a function to turn my vast amount of knowledge into a specific bit of knowledge. And part of this also is that there's this vast boom of needs for training large language models that are bigger and bigger and bigger with more parameters, more bits of information. And that's where they're scraping the internet to be able to generate these large models with more data, because you just need to feed it more to have it have a larger bit of information that it understands. And the current what, am I off the page? No, okay. Some of the current capabilities that are transforming different industries with these large language models and AI today is the ability to do things like real-time translation. If anybody has a Google phone or an Apple phone, they've been able to do the fun thing where you can pull up the translation app and you can in real time talk to your phone. It will then transcribe what you say, so going from speech to text, pump it into these large language models to convert it into the target language that you want, and then similarly convert it from text back to speech in that target language so that you can have a conversation with somebody and do the reverse in real time so that the conversation doesn't lag and you can have a legitimate, Tower of Babel scenario of being able to converse with people across languages. There's a lot of things in here. There's like things like code completion that every CS major loves to probably have. I like it. It's an interesting thing to dive into because I'm used to spending my time with a code editor and an entire page of documentation in one window and side by side and going back and forth to make sure that what I'm building follows the docs. And instead now I can simply ask ChatGPT or Claude or Code or what is it? Microsoft's thing. Copilot, yeah. But I can ask them and they can simply suggest the thing that you're trying to do, here's a bit of code that will do that. And all I have to do now is have a little bit of domain knowledge to say whether that's correct or not. But I can have it as a conversation. Similarly, it's gotten very good at some of the other applications, which is computer vision has similarly had a stop and start sort of trajectory, but it's now taking advantage of this wave of development in AI and being able to do fun things like, here is an image, does it have cancer in it? If it does, let me know and point it out to me so that I can give a diagnosis faster to my patients and so that more lives can be saved. And also there's a lot of things now everybody sees the like TikTok videos of generating images, generating videos that are entirely fake. They've got somebody else's head, they've got somebody else's body, somebody's an animal running around instead of a human. And all of that is because of these large language models and because of this development in AI can then trickle into some of these ancillary research fields, which are image generation, image categorization, content generation. So like I was saying, like Copilot now, there's studies out showing that there's 40% of code now has some form of AI assistance associated with it, whether that's written completely by the AI or it's checked by the AI, but you can now infuse it in entire pipelines of software development, whether it's help me come up with an idea of how to tackle a problem using code, to let me debug a problem that I have an existing code. But it's now becoming so prevalent that basically approaching half of all new code has some form of AI related to it. And it's also bringing a wave of new roles, and it's kind of retiring old roles. So now you've got things like AI engineers. Prompt engineers is one of those things that my personal opinion is that's going to go away because there's no point in having somebody be just a person that asks questions of a machine. You need somebody to have some sort of expert experience behind those questions. Otherwise, you're just throwing mud at a wall and hoping it creates a building. And also, there's a lot of studies that have shown that there's quite a bit of productivity gains, but there's also detriment here because you also have to take time to look at vast amounts of code generated not by you, but by a machine that may or may not do exactly what you asked it to do. And then kind of to get towards that and get towards moving forward, these are kind of some of my roadmap and predictions of where I think it's going. And these are kind of predictions that are not just myself. These are also what you see in literature, but it's things like, obviously, as ChatGPT and others and their models have gone from smaller context windows to larger context windows of what they can understand, that's going to be continuing to grow, hopefully to the point where you don't have to have, if anybody's worked with some of these conversational agents, they only have a time span of so long before they have to drop off and they cannot maintain the information that you have provided to them. Kind of like a human though, they kind of forget over time. But they don't forget over time gracefully, they forget abruptly. So what ends up happening is it forgets the original question that you ever asked it because you're 16 questions deep, and now it doesn't remember the original prompt, and then it's going to circle back to that because it thinks it's new. But with larger windows, that should hopefully become less and less of an issue. And also, with that larger context window, it can do better things like reasoning and planning. You can get more complex problems, more complex solutions that you can ideate over very quickly and not lose that context and not lose what it is that I'm building. So you'll potentially see things like some of the more far-reaching things of like scientific discoveries based on AI coming up with the question, coming up with the model to research that question, and coming up with whether or not that data that they collect results in a new finding. I also see some differences of the mode or the modality of how you interact with AI is certainly going to change in the next couple of years, because we've gone from simply chatting with it to now having it be something that we can embed into our emails, into our workflows of tools that we use. I think that it's going to go to the point where the browser is going to go away, and that browser is going to become an interface to an AI that is going to act. The hot buzzword of the time currently is agents or agentic AI, but you're going to basically have a browser that is an agent for you that will go retrieve the information you want, summarize it for how you need it, and present it to you back to you in the way that you can best understand it. I also think that the middle length projection here is that just like previously over the last 70 years or so, as the AI technology has increased its capabilities, some of the ancillary industries and focuses have also been able to take advantage of that for their own leaps and jumps forward. And I think that one of the big areas that'll do that is actually robotics, because one of the big hindrances currently of AI is, and everybody says AI will lead the world, but the problem is AI is a machine, a computer. It lives on a system. It's never going to do your laundry for you unless it has control of something physical, unless it has the ability to extend beyond the computer and make physical connections with things. And that's where robotics comes into play. You're going to have a hand, an arm, something to move and manipulate the physical world and extend the capabilities of the AI, which gets into the dystopian future, potentially, of AI will become killer robots that go after all humans, or it becomes what is that one, the AI bot that simply butters your toast. And then I put potential for AGI of generalized intelligence, of intelligence that doesn't have itself hyper-tuned to one specific task. It's not going to generate images. It's not going to generate answers to questions, but instead it can do all of them. I think that eventually will come. It will not be the thing that you can have as your best friend. It's not going to be a person with a personality. It's going to simply be a computer. But currently, if you go to ChatGPT or you go to any of these other LLMs, what they're actually doing when you ask a question or when you tell it, generate an image, generate a video for me, is that it's parsing it out to different tools that are trained for different things. It's not one single AI, it's actually multiple AI chained together. But going forward, certainly those are going to eventually merge to where you end up getting one model that's capable of doing all these different modalities. And then going into the far, far future, does it actually have the ability to be a personality? Does it have the ability to reason and rationalize its own thoughts, its own beliefs, its own perceptions? Maybe. I think that that's one of those things that might need to go through a similar AI winter of we get to a point where we're happy with it, it works well, but it doesn't make that next leap without some new inspiration or technological advance in that area. And I also think that knowledge work, which is a very broad category, but it would be anybody that's doing customer service, anybody that's doing airline ticket booking, anybody that's doing taxes. These are all knowledge work. These are all tasks that require a specific bit of knowledge to effectively make a change for their customers. So a similar example would be lawyers. Lawyers are knowledge workers. their knowledge from going to law school allows them to be very effective lawyers and go into court and argue cases. That can be done by a machine at some point, because it's similar to, I model a problem, I model my knowledge that I need in a large language model. I can effectively make those arguments as soon as I can rationalize and reason with the case law that's in front of me. And I think that yeah. And then one of the kind of the new forms of AI collaboration that it's got listed there is that as this dynamic is changing, one of the areas that I researched in my PhD is an area called human-computer interaction, which focused on how do we interact with the computer, what ways does our social context change when we're working with a computer versus another human being. And I think that some of these changes to AI and some of these changes to how AI is presented to people have differing effects of how we're going to socially perceive each other and socially interact with the machine, whether or not we're going to treat it like our best friend, treat it like our enemy, treat it like our boss or our slave worker. They all have different implications for how do we operate and how does society form based around it. And yeah, some of the fundamental limitations that AI will almost, at least in this current iteration, will never do is things like true consciousness. You're never going to have an AI that's going to be depressed at itself and want to commit suicide. You're never going to have an AI that is truly joyous for the moments when it gets the answer right. Because this is the realm of humanity, not the realm of machines. And it can act as though that's the case for itself, but it'll never be a true reaction from a machine. Currently, at least, physical world mastery is beyond the capabilities of AI. It has no ability to reason and rationalize when I say that gravity is different on a different planet. And please tell me, how can I walk on Mars? It'll tell me mathematically or based on physics, based on knowledge that it's grafted from those areas, how that would work, but it would never tell me how does that feel. And so to some degree though, if robotics increases its pace of development as it's going currently, this is more of a challenge, not a hard and fast rule of it will never happen. It just doesn't have the ability to currently do it and probably won't for the next 10, 15, 20 years. And then things like genuine understanding. There's this idea of is the machine truly pattern matching or is it understanding the problem at a conceptual level? If I ask it whether or not we can ever make rocks turn into gold, it may say yes and give me the backstory of all these metallurgy theories from the 1800s, but it'll never help me take the next step forward and say, how do we make that actually happen? Unless that knowledge existed previously by somebody else who comprehended the problem and used their comprehension and their understanding of the context to make a cognitive leap forward. You're not going to see that sort of leap coming from a machine in its current state because it currently represents the knowledge that we understand and have of the world right now. And then similarly, just as much with comprehension is this creativity side. It'll never creatively come up with solutions that we don't already have a context for. And so kind of some of the key takeaways, at least if you're a computer scientist or wanting to be, is that AI is powerful, but it's a tool, and it's a tool to augment human intelligence. You can currently use it as your secondary in a project where you need to come up with ideas on how to present something or how to develop a product, but it can't replace you completely. You can't simply give a machine a problem set and say, come up with a solution entirely of your own. And I'm not going to tell you what the problem is. I'm just going to tell you, come up with a solution. That'll never come up with the solution that you want because it doesn't know the problem. And the only way that it'll know the problem is if you walk through it with it and you refine that problem and you refine that solution with it. And then similarly, coming to an understanding of what AI is and what it isn't is going to enable anybody that's in the computer science field to be able to use it effectively. If you don't understand where it's going to break down, you don't understand how a context window works, you're going to be surprised at the results, and you're going to be surprised that you're not getting the results that you expect out of an AI assistant or an AI code completion machine. So some of the things is that you have to learn to work with it. You have to learn how to leverage what it's good at and what it's bad at to get the correct output that you need. And also, kind of focus on the human aspects that make us unique compared to an AI system, which is never going to be that we have the best mind at quizzing it ourselves and coming up with answers to quiz questions. It's going to be that, can we come up with novel questions? Can we come up with interesting insights into problems that don't normally have a connection across some field of knowledge or some bit of information? And with that, I will take questions.
So folks in the room, feel free to go ahead and ask questions. Folks online, you can go ahead and unmute and go ahead and ask your question. We can hear you here. Okay, while they're thinking about their questions, I've been listening to these to folks who what would you call the pundits, if you will, who get on TV and radio and talk. I was listening, for example, this is not a pundit, it's somebody who's in the middle of it, Zuckerberg, talking about super intelligence and an AI system that would assist you. How real do you think these things are, or are we there?
I think it's a little bit of a catchphrase to say super intelligence, because at some point there's this idea of it's black magic.
Yes.
And electronics has this of don't touch this component, you'll release the black magic of it. We have it as well with software of it just works, don't change it, it's black magic. In some degree, there is a bit of that. And to say something is not only going to be intelligent like us, but surpass us to be super intelligent, I think is a far reach, considering we don't even know how to define those bounds. And all of these models, all of this AI has always been that we can define a model that can either teach itself or we can teach it by giving it what's the right answer or what's the right question. And if we don't know the right question or the right answer, we're not going to be able to teach the machine to make those creative leaps forward. So we're not going to allow it to be able to like surpass us as well, because we don't have the capability of doing that. So in some respects, AI is a reflection of humanity. And I don't think Zuckerberg knows that. I think that to some degree, he's one step removed from the technology that's being developed.
So if you folks want to ask the question, go ahead and verbalize it, or you can put it in the chat if you prefer, and I can verbalize it for you.
Yeah, I had a question. Are you able to hear me okay?
Yeah, we can hear you, Seth. Go ahead.
Okay, cool. I was curious, based on the history, do you think we're experiencing a kind of novel point in history, or do you feel like this is mirroring or reflecting something that we've seen before?
I think the solution that has unlocked the current era is novel. I think the pattern that we're seeing is similar to what's been in the past. It's been that one new novel idea, one new novel way of modeling this problem of artificial intelligence has unlocked a whole industry, a whole bit of research, a whole bit of excitement in this area. And then it's died down when expectations get ahead of where these new and novel techniques can actually get to. And so it's been the winter concept is kind of a good analogy of it, that we have these booms that have a summer, it's very bright, it's very hot, it's very exciting, but then we have these winters because we've gotten too excited and we have to have an alternative. And that other side of the coin is that we start prescribing to the AI something that it's not capable of currently. Does that kind of answer your question, or was there a secondary part to that?
No, that was awesome. I have another question after, unless someone else has something they wanted to ask.
I don't see anybody on track, so go ahead and Seth.
Okay. The projections you were talking about earlier for how AI may or may not evolve, Does that take into account some companies like Microsoft wanting to start using things like nuclear power to um, power their like AI modeling plants?
So certainly with the emergence of LLMs, this has kind of been at least until recently, until some DeepSeek and some of the like Chinese breakthroughs that they've had of showing that smaller models work. But other than those counterpoints, it's primarily been a race to how big can you make these models, and the bigger is always better is kind of been the analogy for the last 6 years. And so it's always been if you're going to make something bigger, you need more space, you need more memory, you need more power to power these machines that use all this more memory, more space. So that's where like the demand for nuclear or alternative bits of power has come about, because I think that that's a little bit more of a political solution. It's I want to build these large models, but I don't want to have the communities that I'm having my data centers located in an uproar ready to pitchfork and burn us down. And so looking at alternatives like nuclear is probably a political solution rather than a technical solution.
Gotcha. Okay. And then I was recently hearing a talk about them using quantum testing out using quantum chips for a new way of kind of processing data in these LLMs, like moving away from tabular data. Do you kind of have any sort of perspective or opinions on how that may or may not affect things? Since it does seem like quantum is kind of something where, like you were saying earlier, it's that black magic. Like it seems like it could do more than what it actually might.
Yeah, I mean, again, this is so quantum physics and quantum mechanics and quantum computing are all these ancillary industries that are also trying to make breakthroughs. And this is can we apply AI to an area? But yeah, the modeling of information in a quantum system would be vastly different than what it is currently today. But also the way that data is represented for each of the kind of subfields of AI is already not tabular anyway. There's a lot of systems that represent their data in streaming formats that work in real time for processing things now. And the way that those are represented is simply like slices of information pie that assume that things are going to change over time and use the model to reason about those changes and predict forward. But also neural nets, also the way that they're set up isn't really a tabular single row interface anyway. It's a little bit more of an organic system style of representing information on graphs. So graphs have been traditionally actually the data type that most resembles what's happening inside of an LLM or an AI system.
Yeah, learning the neural net stuff was definitely kind of a head trip the first time around.
Yeah, the math is huge behind that, and that's an area that I never touched. I actually started grad school before this AI boom. And so when this AI boom started, I actually didn't touch it for several years. I have not touched AI until the last 2 years, and now I've run with it. But I basically finished my PhD assuming that AI didn't exist, or at least this AI boom of this current generation didn't exist.
So realistically, when you interact with AI, when GPT-3 came out, and you could ask a question and get an answer that looked like was a human on the other end, it was very exciting.
Yeah,
It was very exciting. I mean, if you see that compared to how you used to have to do it to get the information, you'll say, wow, this is pretty awesome. But when you look at what has happened since then, the information has become more current. They have all the latest and greatest data. More data has been consumed.
Mhm.
But at the end of it, is still kind of to me, it will look like a very over glorified search engine that puts the answer. The money hasn't got in there, so there's not advertisement to mess you up.
Uh-huh.
They get the searches and they compile it in a very nicely spoken, written format.
Uh-huh.
But it's nothing more than the pure search that was happening before that time. So I'm wondering if there is a wall that we are hitting. People are projecting, I had to type in my question in Google, find a search, compile the search information into something that was presentable to human. And one day that went from all of that to where I can ask a question and the finished product, which is that finished answer, comes to me.
Yeah.
But if you look at it, I mean, if you ever get on one of these chat bots for a really fancy company who's spending a lot of money on it, or Cursor who helps you write code,
Yeah.
and you see that since that jump to a presentable information coming back at you, there doesn't seem to have been a significant leap forward, what I would call a leap forward since then. So I'm wondering if you are really hitting a wall, which is.
So I would say there's a little bit of a counterpoint to that, which is that it's not just a glorified search engine, because so if I wanted to find, say, all images of cats falling out of trees, it's a very specific question, and unless Google or anybody else in 2008, 2009 had images tagged with cat falling out of tree, it wouldn't give me that result. But now, using an AI model and an LLM, it can take it and say, what do I see in this image? I'm going to parse and understand this image well enough to know that there's a cat, that cat is in motion, that cat is falling out, and there's a tree. Probably the thing that they want is that. But it's generating those tags on its own from the way it can understand the image. Whereas before, if it wasn't tagged, it didn't exist in a search engine. And so I think that some of that is, that's the new cool, that's the new hot of what this is enabling, is the ability to understand different modalities, different things, images, video, audio, somebody else's statement in another language, but I need it for a specific context in my language. It's reaching across a lot of these things. And the other, I don't know that there's a wall, because one of the new things that I'm seeing, and everybody is seeing now in the last 6 months, is the increase of agents and having AI not just be the world's encyclopedia of knowledge, but actually be the world's encyclopedia of knowledge supercharged for me and customized to me. And me being able to say, here's my private data, here's my calendar, here's the things that I know that I don't want the world to know, but I want my agent to know, and I want my agent to give me a customized, personalized result for. And having agents that can take that information and then act on it and potentially go and contact my friend that's in another country, maybe in another language, make a reservation for a restaurant because I'm going to go visit that town and city, and put it on my calendar in a place that makes sense. And that sort of string of a problem would not be possible without something that could reason across all of these different types and information sources. And also, it wouldn't be able to act simply as a generalized intelligence or a generalized bit of knowledge, because it needs my specific information to make that call.
I was seeing that as being a jump from a Web 1.0 to Web 2.0.
I would agree there.
There was APIs, and as a matter of fact, I was watching this video and something called 8N8. I don't have no idea what it is, but what sounded to me it was a YouTube video I was watching, is basically how you can build an agent without writing a program. They have menus on both sides, and you kind of connect these agents together. But it reminded me of Web 2.0 when they were selling Web 2.0. That's kind of what they were doing.
The democratization of the web, and this is similar with democratization
I see
of
some
AI.
folks unmuted their microphone, so you don't want to occupy all your time. Scott or Seth, did you guys have a question? I see you unmuted.
Yeah, this is Scott. I have a question. Thanks for your talk, Nick.
Yeah.
So you're in industry, and you say you're a full stack developer. In any of your industry projects, have you ever had to incorporate a chatbot into a website, or have you ever had to kind of incorporate one of these things into one of your industry projects?
So a lot of the parts of the industry that I focused on and worked on was that I kind of fell into working on legacy software and modernizing legacy software. And the kind of customers and the kind of industry area that tends to have legacy software and tends to want to keep whatever functionality that has around, doesn't tend to want to strap an AI to it. And so for a long time, I didn't have any interactions industry-wise with AI until recently. I've had actually, I'm just about to start a project through my company there with another company working on setting up MCP servers, model context protocol servers that are basically the glue that allows something like a chatbot LLM to interface with another data source. Typically, especially for like corporate companies, it's your proprietary data information, your customer information, your backend stuff that you don't want exposed, but you want to have a layer that allows it to be exposed to a chatbot for you. And again, this is like the agentic side of stuff of how do you personalize it for you. And so
Okay.
I'm just now starting to get into rolling some of the stuff out on my own.
Okay, so you have been thinking about how to do this, because this is, when you just hear the popular press, it's always about the models. But I've always kind of thought, like if you're a consultant or you're trying to prepare students at a college to go out and be productive in this new field of AI, how would you prepare students to come at this? Like if you were to go out into industry, how would people typically work in this field? What are the activities that they have to do? Because it seems like they don't actually do model development. Those are open source and you get those somewhere. But then what are the next steps? What are the steps you have to kind of go through to incorporate, say, a chatbot into a website?
Yeah, well, so yeah, there's definitely a little bit of a bifurcation of the like AI landscape of jobs. There's the people that are building these models and pushing the science forward.
Right.
But that's kind of been true also for like computer science in general. Somebody's pushing the language development, somebody's pushing the tools that you use to make the products. And then there's the practitioner side of the people that are then taking those models or those tools and using them in useful, novel ways for different parts of different industries. And I think that for students, if you want to step into this AI world, it's which side of that spectrum do you want to be on? And certainly you could wander back and forth between both sides of it. I understand a little bit of it from the mathematical side just because I have a background in statistics, but I'm not going to go and train and build my own models because I simply don't want to stand up an entire data center to do so. So I think that the practical side of it is whichever area you were previously passionate about and wanted to go into, and the reason you came to computer science, it's still probably going to be there. It just may be that you also have an assistant that's artificial behind you or beside you, working alongside you with it.
Okay.
And so I would say focus on understanding what is and is not AI, and then focusing on how do you leverage that understanding to use it correctly for the different areas that you're interested in working in.
Okay. Thank you.
Michelle, did you have a question? Oh, yeah, you have a question.
So I don't like AI, and one of my goals is to learn AI so I can figure out how to destroy it in the future. Then my friend told me that there are already people who are trying to do it, and it's like they have like websites that can like maybe they're trying to make websites that can trap AI. So when AI try to look into their website, the AI like trapped and can't go back. So do you know any other way to interrupt what AI are doing or how this?
So this kind of dips into the ethics side of AI, which is the how do we as humans deal with AI from an ethics and sort of humanistic perspective on it. The like trapping AI, yeah, that's part of the question of like who owns data, who owns the data that AI is training on, are they being properly compensated? Will artists be able to take advantage of the fact that they've created something that's now being ingested by AI? Will they be able to benefit from this as well? And so some of that trapping or trying to halt the crawl of AI across our entire information landscape is kind of in that area. And I think those are still open questions. And I think that it's an open question that everybody still has to rationalize and reason with individually and as a society and come to like the rational conclusion of what works for us. But in terms of
Yes, no.
working with AI or destroying AI. I don't know that, so kind of this would be the kind of on the same realm of saying that I don't like computers. I don't want to be involved with computers. There's people that have still subscribed to that, what is it, almost 90 years after the initial invention of transistors and computers as we modern know it. They are still on the scale of I would not rather have a computer, let alone an AI in my home or in my life. And I think that it's a choice, but if you're going to work in computer or science, it's kind of infused at this point. It'll certainly probably have another AI winter to where you don't have to care about it or see anything in the news about it. But I think that it's still kind of going to be infused going forward. And so in terms of destroying it, you could probably just have it destroy itself. There's something called chaos engineering. Typically it was a research area on how to break systems or how to break encryption or how to break some sort of a network. And it was meant to be a testing mechanism, but it's similarly that AI is also kind of needing to be tested. And one of the testing methodologies is have AI test itself, have it combat itself, and have it basically make itself better through combat, so to speak.
What is it called?
Chaos engineering.
Thank you.
Let's see, anybody else has a question? Michelle? Oh,
Actually, I'll just have one follow-up question. You mentioned an MCP server. I just heard that term like last week, and as like you say, it kind of connects your AI up to the customer's data that you want to be incorporated into a like a chatbot.
Yeah.
And I felt like there is kind of an architecture then developing here. There's kind of seems to be a standard setup for people.
MCP is actually what the standard is.
Okay, so can you just kind of highlight what that is exactly? Like I said, I just heard that term, and I kind of, from the context, I was like, okay, but what do you connect it up to? What does it connect to? And
So a good example of it is so from a company perspective, say you have a lot of customer data. You've been in business for 20 years. You've got customer data going back 20 years, and you've got it all stored in some sort of a CRM system. And that same CRM system may be set up in our traditional sense of like a database system with different relations between different tables, and that's how it's architected. And then maybe you have a group that does marketing and maintains all your different marketing information, and you want to target specific customers based on specific data, but you want to come up with new and novel ways to personalize that marketing, but you don't want to expose your customer data, and you don't want to just throw all of that customer data out there for everybody and anybody to see by uploading it to ChatGPT or something like that. Because if you're especially if you're on a free account on all these guys, anything you put in there, it's training on that information. A lot of them, if you pay, they'll keep your information. They won't use your information to train, but it doesn't mean that it's necessarily safe and not violating some sort of legal or company policy. So the MCP server standard is allowing you to make that connection with those guarantees in place of this data is not going to be leaked. It's only going from my data source or my customer information, and it's being passed to an LLM or an AI model to then make the inferences that I want. And maybe it creates me a whole marketing campaign with different images for different people. Because maybe some people are really big Yankees fans over in New York, but I don't want to send that same bit of marketing to the people in Boston because I'm going to offend them.
is it the MCP that enforces the privacy, or is it up to the LLM you're contacting to follow the rules of the MCP and not integrate that information?
It's the MCP itself that actually maintains the data. So it ends up being that the inferences from the AI model are being pumped into the MCP server, and the data that it's wanting to use those inferences across from is also coming in from the data sources. So it's kind of a marriage link point between the two, but the MCP is the one that's maintaining whatever the privacy policy or data retention policy or access that you have.
And I've noticed a lot of companies now talk about being able to switch in and out the LLM they're using depending on the day.
Oh,
So
yeah.
there seems to be a socket of some sort
Ah,
that you could put different LLMs
I mean, there's a
in.
market out there, Hugging Face is a
Hugging
big,
Face, yeah.
it's a big
Is that-
market for figuring out applying different models that are open source and released. Because there's not everybody is open model. There's a lot of companies that are running closed source models. But yeah, you can swap them in and out, and the MCP layer would probably allow you to do that in terms of swapping them in and out. Wouldn't matter because a lot of these are basically they're tool packages that you could download and run. It's just that you have to have a system that has 150 gigs of RAM available to it and 10 terabytes worth of data storage, which is not unheard of. People have giant gaming systems that can do this, but you have to be able to have something like that reliably to crunch and run these models, at least at a fast pace. If anybody's played with rolling your own model or downloading some of these models and trying to run them, you can run them on a Raspberry Pi, but the rate at which it's going to give you the output is going to be very, very slow. And one of the measures of that is tokens per second. And that token is typically like if you wanted it to generate textual content, a token would be a word.
Yeah.
And you would end up getting 1 word every 30 seconds as opposed to 10 words every second.
All right, so anyway, I have to go, Ilan. So thank you
Well,
very
actually, we have come to the end of our conversation. This is the time.